Hello guys, so today I'm going to be explaining the homogeneous form of the differential equation. So if we have dy by dx as a function of y by x, then it is in the homogeneous form. What this means, or a good way to check if it is in the homogeneous form, is to let y equals to something times x, or as a function of x, and put it back to the original equation, and all the x terms will cancel out, and if that happens, then it is a homogeneous equation. So let's see with an example. So if we have dy by dx is equals to y by x minus 2, then what you can do is let y equals to vx. Then you can put vx in here, so you'll get dy by dx is equals to vx by x minus 2. Here the x terms cancel out and we're left with v minus 2 only. So if you want to solve this type of equation, then you have to go from dy by dx to dv by dx, because we're dealing with v, or function of v. So here we simply differentiate both sides with respect to x. Then we use the product rule. We get v dx by dx, which is just 1, plus x dv by dx. So we just put that here, v minus 2. Simply we cancel out the v's, and we have to put dx in the numerator and the function of x with dx. So this goes here, that one goes down, so we have dv equals to minus 2 dx by x. So we have, we'll just integrate here, so we'll have v equals to minus 2 ln x. I'll just do plus c, and here we have to put the v back into the function of x and y, because in the original equation we have in the function of y and x. So from here v will be equal to y by x plus c. That is all. Now let's do a more difficult question to make you understand the concept more. Now the simplest thing to do here is, first we get dy by dx. Now dy by dx is equals to, well, this part goes down here and that part stays there. So we get y x plus y x x minus y, and the dx goes down here. Now we let y equals to vx, so putting it back, dy by dx will be equals to vx x plus vx by x minus vx. So first of all, we can cancel these v terms, and also next we can take the x common. So we have v into x 1 plus v by x 1 minus v. These also cancel. Now we need dy by dx. So from here we can get v plus x dv by dx. This step will be the same for every homogeneous form, or for almost all the homogeneous forms. So we will have v plus x dv by dx equals to, let's just multiply this out, so we get v plus v square by 1 minus v. Now let's put the v over there. Dv by dx equals to v square plus v by 1 minus v minus v. Now let's do some basic algebra. So we have x dv by dx is equals to v square plus v minus v plus v square by 1 minus v. Here this v and that v cancels. So we get x dv by dx is equals to 2v square by 1 minus v. Now we have to put the function of v with dv and function of dx with x. So what we can do is put the v function over there, dx over here and x over here. So we get dx by x is equals to dv 1 minus v, that goes over here, this part goes here, 2v square. But you know what, we can actually leave the 2 just here because it is just a constant, so we can write 2 over here. Now let's integrate both sides. So here we will get 2 ln x, but for here we have the integration of 1 minus v by v square. So let's just directly write it in the next step, and we can solve the integration over here. So the integration of 1 minus v by v square dv, we can just split the fraction. So we have 1 by v square dv minus v by v square, the v's cancel, we get 1 by v dv, and we can use the power rule here. This is v to the power minus 2, so the power rule is power plus 1 by the n plus 1, so we'll get v to the power minus 1 by minus 1, which is minus 1 by v. So over here we'll get minus 1 by v, and over here we'll get minus ln v. So let's just write it over here, minus 1 by v minus ln v. Now one thing, we have to put a constant, because after integration we get a constant. So since there's ln and ln, let's make it easy for us and put ln c. In fact, to make it even more easy, let's put 2 ln c so that we can combine these two. So we'll get 2 ln x plus ln c, and with the log property we get ln c into x, that is 1 minus v minus ln v equals to this. So this goes over here, 2 ln cx plus ln v. Well, again using another log property, the coefficient on the front of the log can go as the power of the what is inside the log. So you'll get minus 1 by v equals to ln c square x square plus ln v. Now here c square is just another constant, so instead of that we can write ln c dash to represent a constant, x square into v. So now we need to put v as the function of y and x again. So we know v equals to y by x. So minus 1 by v or 1 by v is just x by y. So we get minus x by y is equals to ln c dash x square into y by x. X and this square cancels, and minus x equals to y ln c dash xy. And finally we can put the x over here, so we get x plus y ln c dash xy equals to 0. So we have just solved a homogeneous form of a differential equation, and this is the required general form. Thank you.